Hi everyone. We're now on the fourth section of chapter 9 here. What we're talking about is direct, joint, and inverse variation. We just did a bunch of work with graphing rational equations. Now we're going to take a break from that and we're going to see how two variables relate to one another. There's going to be three different relations, and that's direct, joint, and inverse. So the first thing we're going to talk about is direct variation. Direct variation, the definition is this: as x increases, so as one variable increases, the other variable, which in this case y, increases as well. Or, if you go the exact opposite order, as x decreases, y also decreases. So they're always going to have the exact same movement. As one goes up, the other goes up. As one goes down, the other goes down. We'll just take a simple example from everyday life. School, music, sports. The more you practice something, the more you study, or the more you practice your scales, or the more that you practice your free throws, or the more you practice, whatever the case might be, the more you practice, as that increases, your achievement is going to increase as well. You're going to get better grades. You're going to be a better free throw shooter. You're going to get better at playing the alto saxophone, whatever the case might be. The more you practice, the better your achievement is going to be. They go in the exact same direction. Or if you go that opposite direction, the less you practice, right, the worse off you're going to be. Your grade is going to go down. Your sports is going to decrease. You're not going to be a very good trumpeter or something like that. The less you practice something, the worse you're going to get at it. Oftentimes these relationships are used in science. I know that such as like if you're dealing with maybe heating up a gas or heating up a chemical, something like that. As the heat increases, your molecular movement increases as well. Those atoms and molecules, they go faster, they heat up. So the more you heat something, the faster those molecules are going to move. So those also have a direct variation relationship. The equation that we use for this today is going to be y equals kx. Here's our two variables, so as one increases, the other increases, or as one decreases, the other decreases. And then k, don't ask me why, but k is going to be our constant of variation. I don't know why they abbreviate constant as being a k, but just to let you know, whenever I say constant of variation, I'm talking about this letter k right here. So that's what we're going to find in a lot of these problems. So let's put this to practice now. For this first one, the first sentence is huge. It says y varies directly as x. So that's telling you that that the variation is direct variation. So that tells you what formula you're going to use. You're going to use this one, y equals kx. So if y equals kx, you're first going to find your constant of variation k. Because you know what y is. Y is 12 when x is a negative 3. So that's what you're going to substitute in for your variables. If y is 12, put that right there. 12 equals k, which we want to find, multiplied by x, which is a negative 3. So we're going to solve for k now. Obviously, all you have to do is use division, divide both sides by a negative 3. We found our constant. Our constant variation is k equals a negative 4. So if we know that, it says find y now when x equals 16. So now, class, our equation was this one right here, y equals kx. Now we know what k equals. We can say y equals k, which is a negative 4 multiplied by x. So if that's our new equation, let's find y. What is y when x is a positive 16? So let's put 16 right in there. Y equals a negative 4 multiplied by 16. So what is y in this case? We simply multiply and we get y equals a negative 64. And this is the answer that I'm going to look for on a test. This is the answer that Excel Math is going to be looking for on our next objective. Now that you have a little bit of introductory into that, why don't you guys pause the video, try number 2 on your own. Once again, it's going to vary directly, so use the notes that we did in number 1 to try to solve number 2. Alright, let's see how you did. Once again, because it varies directly, you're going to use the equation y equals kx. So with that, y is a negative 15, so that's going to go on the left side. That equals our constant k multiplied by x, which in this case, x equals 5. So you're kind of doing two different you're solving two different equations in these problems. So solving for k equals a negative 3 when you divide both sides by 5. So now that we know that if y equals kx, because they vary directly, y equals a negative 3 times x, because our k is a negative 3. So now it says find y when x is a positive 3. So y equals a negative 3 times 3. What does y equal? Y equals a negative 9. There's our answer for that one. I hope you had success with doing that one. The next type of problem is very similar, actually. It is joint variation. Instead of just y and x, two variables, there's going to be a direct relationship with two or more quantities on the right side. It was just y equals kx without the z. But now we have another variable that's also acting on our constant. So y equals kxz. Or if there was three variables, it would be y equals kwxz, or something like that. However many variables there are, you're going to multiply that with k. So you do these problems the exact same way. Looking at this one, suppose y varies jointly, so this is going to be huge. If it varies jointly, you know you're going to deal with this equation. If y varies jointly with x and z, find y when x is 8 and z is 3. So class, if you're looking at this one now, it says find y when x is 8 and z is 3. If we want to find y, we first have to know what k is. If we want to find what y is, we're going to multiply k times x times z. Well, we don't know what k is, so let's save this for last. We first want to find what our k value is. So we're going to use this part in green to find our k value. If y equals k times x times z, y is 16. So let's put that in there. That equals k times x, which is 2, times z, which is 5. And now we're simply going to solve for k. Well, this on the right side equals 10. 2 times 5 is 10. So now we have 16 equals 10 times k. Divide both sides by 10. And what do we got k to equal? K equals 8/5. So if my constant of variation k is 8/5, now let's do this part. Find y, so y equals kxz. And we now know what k equals. Y equals 8/5 times x and z. So now find y. What is y when 8/5 is multiplied by x? X in this case is 8 times z. Z in this case is 3. So all you need to do, class, is multiply all three of these by each other, and we have our answer. Y equals 8/5 times 8 times 3, which you should get as a decimal is 38.4. As a fraction, you should get 192/5. Either answer is just fine with me on a test. Obviously, when you're doing your Excel math, you'll have to see if they want their answers in fractions or if they want it in decimals. Now that we did number 3 together, why don't you guys try number 4 on your own? You do it in the exact same way. Pause the video, please. Try it on your own. All right, let's see how you did. Suppose y varies jointly as x and z. This is big. This tells you that you're using this equation. So if y equals k times x times z, find y when x is 10 and z is 5. Once again, class, you have to save this for last. You can't find y when you don't know what k is. So save this for last. Let's first find what our constant of variation is. You're going to use this information to find k. Y is 12. That equals k times 8 times 3. Proceeding. K is multiplied by 24. That equals 12. So to get k all by itself, divide both sides by 24. Your constant, k, is a half. 12/24, which is 1/2. So now, being that y varies jointly with x and z, if y equals k times x times z, and k is 1/2, y equals 1/2 times x times z, we're now going to find y when x is 10 and z is 5. So y equals 1/2 times 10 times 5. Multiply all three of those by each other. Half of 10 is 5, and 5 times 5 is 25. Y equals 25. And this is our answer. So hopefully there's no questions on direct variation and joint variation. What I want you to maybe get in the habit of is these two are very similar. On the right side, they're all multiplied by each other. Whether it's y equals kx, it's a product on the right side, or y equals kxz, it's a product on the right side. Everything is in the numerator. When we now get to inverse variation, we're dealing with a whole different animal. Okay? This is where, as x increases, what happens to y? It decreases. Or vice versa, as x decreases, well then y is going to increase. So they have an opposite relationship, or an opposite movement. An example of this, let's kind of keep on going with our science examples. Let's say when you decrease the volume of a gas. So if you put it in a container and you decrease that volume, as it gets smaller and smaller, what happens to the pressure? The pressure goes up. Think about maybe a balloon or something like that. If you try to squeeze that balloon, if you try to really press it together, what happens to the pressure? Boom, it goes up and up and up until all of a sudden, boom, it pops or something like that. So as you decrease, as one goes down, the other goes up. We could think of thousands of examples of stuff like that as well. One might be, let me think here. Let's say you're a musician again, or a piano player, or something like that. The more you practice the piano, okay, the less mistakes you're going to make. So as one increases, the other decreases. And there are plenty of examples using inverse variation. But here's going to be the equation. It's very different from the other ones. This one has a denominator. So this one is kind of a rational equation. It has a variable in the denominator. So y equals, the k constant is in the numerator. Our other variable is in the denominator. If you were to just look at this for a second, let's say we have 6 equals k over 2. Something like that. You know, never mind. I was going to have an example, but that's just dumb. Let's just get on to our problems. If we go onward, it says, number 5, r varies inversely to t. This is big. This tells you what equation we're going to be using. And if it says inversely, we're going to be using this equation right here. So y equals k over x. If r varies inversely as t, and r is 18 when t is a -3, find r when t is a -11. So this is the part that we're going to do last, because before we can find r, we need to find our constant of variation k. So instead of y equals kx, I suppose we would be using r and t. So r varies, which means equals, inversely, so k in the numerator, and the other variable t is in the denominator. So now we have r equals k over t. R is 18 and t is a -3. So 18 goes on the left, that equals k over t, which t is a -3. You multiply, to get k all by itself, you have to multiply both left and right sides by a -3. And so what do we get when we do that? K equals a -54. So this is our constant of variation. So now, instead of this, we have r equals k, which is a -54, over t. So now let's find r when t is a -11. So r equals a negative 54 divided by t, which is a negative 11. If we do that, a negative divided by a negative is a positive, so you can keep it as r equals a positive 54 over 11. I would have no problem with this. You could answer it this way on your test. If Excel Math uses it as a decimal, obviously just put it into your calculator, 4.91. Either one is fine with me. All right, you guys try number 6 on your own. Let's see what you come up with. It says A varies inversely as B. So this is going to tell you that we need to have our constant of variation in the numerator and our other variable in the denominator. So if A varies, A equals inversely K divided by our other variable, which is B. A is a negative 6 when B is 2. So A is a negative 6, K over B. B is a positive 2. Let's find our constant of variation. Multiplying both sides by 2, we get K to be a negative 12. So once we know that, if we know that A equals K over B, and we found what our constant of variation is, it's a negative 12, A equals a negative 12 over B. So now let's do this part. Find A when B is a negative 7. So A, what is it when a negative 12 is divided by B, which is a negative 7? Well, quite simply, the answer is a positive 12 sevenths. A equals 12 sevenths. And there's our answer. Last one. It's really not done any different, but it is just a little bit more tricky because there's more mathematical operations that need to take place. S is inversely proportional to the square of t. Inversely proportional or inversely related or inverse variation, they all mean the exact same thing. To the square of t. So this right here, class, is going to be big because this tells you what equation we're going to use. If S is inversely related, S equals, if it's inversely, it means K is in the numerator, and then the square of t is in the denominator. So the square of t is the same thing as saying t squared. So there's our equation. This is going to be big. Now it says S is 1/16, so 1/16 goes over here. So that equals K over t squared. T is 8, so 8 squared. Once we find our constant of variation, then we're going to tackle this green part. But first, let's find our constant of variation. So now we know that 1/16 equals K over 64, because that's what 8 squared is. It is 64. So now let's multiply both sides by 64 to isolate our variable K. So K equals 1/16 times 64. If you do that, our constant of variation is 4. K equals 4. So let's go back to this equation where we started off with. S equals K over the square of t. And K is the number 4. So S equals 4 over t squared. Now let's do this green part. Find S when 4 is divided by t, which is 9 squared. Make sure you don't forget that squared part. It's the square of t. So we have S equals 4 divided by 9 squared, 81. Here's our answer for that one. If you took good notes here, if you understand those 3 concepts of direct, joint, and inverse variation, I don't think you'll have any problems with Objective 106. But by all means, ask me questions if you have them.